It is currently 10:52 p.m. as of yesterday, and I'm just starting this project. Welcome to Graphene.
Graphene is a recently discovered material that is stronger than just about anything we've ever found before. Made up of purely carbon in single and double bonds, one sheet of graphene is only 1 atom high. Here, we have a scientist loading a sheet of copper into a furnace. This furnace will act as a plate for which the graphene will bond on top of as different gases like argon are added to purify the graphene. Once the copper is pulled out of the oven, the scientist plates the thin layer of graphene with gold foil to remove any surface contaminants. A plate of silicon is then scored by a diamond-tipped knife and is broken into smaller pieces which will be used to attach the graphene to. A thin layer of plastic is then dropped on top of the material and placed inside this device where it will be spun around violently to ensure an even coating of plastic. The piece is then removed and attached to tweezers, which is attached to an electrical source. Once placed in water, the copper creates bubbles, which then removes the graphene from the copper. To remove the piece of graphene from the water, the piece of silicon is used to catch the floating graphene. Part 1. Structure. Graphene is a two-dimensional hexagonal lattice that is actually technically still it's a crystal. It's just a two-dimensional crystal. And the diagram for it is just, instead of your face-centered cubic or body-centered cubic, you just have a square with 2 carbon atoms. Structural defects and how are they and how many are there, and what happens in graphene. There aren't any. Graphene is perfect. So when I say there are no defects, I mean there are no extrinsic atoms that are being involved in the structure. However, dude, go home. Well, there's one structural defect. It's called SW5577. That refers to the 2 pentagons, 55 and then 77. Now we're going to talk about the properties, starting with thermal! Due to its simple and elegant nature, graphene is a fantastic thermal conductor. Its thermal capacity is actually twice that of diamond. Property number 2. Mechanical properties. Graphene is one of the strongest materials humans have ever made. And because of that, it does something like this. When a bullet would go through a sheet of graphene, it would enter and actually bend the graphene. The graphene would resist it to a point where it would bend and create a cone-like shape. Whereas a sheet of titanium, the bullet would just, this is a very microscopic level. A bullet would just create a small hole, rip through it like butter. However, there is one flaw. When graphene is induced into a small or large electric field, the mechanical properties and the strength of graphene actually weaken.
Graphene conducts electricity very well. This is because in graphene structure, each carbon atom is covalently bonded to 3 others. This atom contains delocalized electrons that can carry and pass an electric charge extremely well.
To give you guys an actual example of how small a sheet of graphene actually is, the average diameter of an atom is anywhere from 0.1 to 0.5 nanometers. The size of a sheet of graphene is 0.335 nanometers, which you can obviously tell is in that range. One fun fact about graphene is that you actually use it every day because, here, I'll show you. This pencil, the lead, or I guess it's technically called graphite now, is just a bunches of layers of graphene that when they come off look like this. We have been using graphene our entire lives and have had no idea that it's going to change the world. As you can see, even when you do the simplest search on YouTube on just graphene, information about it with massive YouTube channels explaining how even in its earliest stages, this material could change how we live. People and companies are continuing their research and have already started designing things from flexible smartphones to large-scale supercapacitors with this material. Along with these new technological advances, graphene could serve as a material that would make solar energy more efficient, as well as being able to possibly filter the salt from water. These two advances alone would create a sustainable future for everybody. And that concludes my presentation. Hope you enjoyed it.